So thank you everybody for joining me once again here on C# Corner. This is my performance tuning checklist. I'm going to be passing along a lot of tidbits that I use as a consultant when I'm going into your systems to make sure you have all your best practices aligned, and a couple other tips that you can check within your environment. For those who don't know me, I'm Monica Rathbun. I'm a consultant with Denny Cherry & Associates. I am known as SQL Espresso inside the database community. You can find me on Twitter at SQL Espresso. I've got my blog where I talk about many of these things. You can follow up on that at SQLespresso.com. I'm very involved in the community. You can hit me up with questions at any point in time. And you can also find my articles on C# Corner. I share them there as well. What a great site. Hopefully you guys are taking advantage of that. So my presentation for you guys with this one, it's usually a 75 to a 90-minute session. I am going to do my best to squeeze it in an hour. I will apologize if it's a little fast, but I will do my best to get you guys all the content that's available. If not, I do have the presentation slides available on my website. Usually my presentations rules are in person, interrupt me, ask questions. Please use the chat. And ask all the questions that you want. If I'm not able to answer them on camera, I will answer them in the chat after we finish up. So we're going to start with best practices. It's always really important to get the foundation of your environment as good as you can get it before you really kind of dig into huge tuning in your procedures and other aspects of your environment. Best practices is always where we need to start. And this is where we start our checklist. We're going to go through these 9 items and a couple more. And as we go through, I would expect and hope that you're going to go back to your environment and look at each and every one of these and double check your system to make sure you have done this. This is the simplest one I like to start with, and I find many people miss because a lot of us as DBAs don't actually touch the Windows configuration. This is something outside of SQL Server that makes a huge impact. And that is the power plan, not only on your server itself, but if you are in a virtual environment, this would be your VM host. You want to make sure that you are set on high performance power plan. Now, by default, and lots of Windows admin automatically set your power plan on balance. And what that does is it holds back some of that power, and it kind of just revs your engine and it keeps it going, and it's kind of a balanced thing. You want to make sure, it actually revs your engine and then it stops, it revs your engine and then it stops, and then revs your engine and stops when it comes to CPU. You actually only end up using 70% of your CPU. Look at that number. You end up losing 30% of your CPU power by being in the balanced power plan mode. If you are in high performance, then that CPU is going to rev and you can actually keep it up high and use it. You don't have to have that beginning up and down usage that you're going to lose here. There's 70% of the CPU is only used in the balanced power plan. So you have a degradation in performance by 30% by not having this power plan. This is a huge thing. It's usually out of the realm of the DBA, but you need to make sure you're double checking this again on your server and on your VM host if you are hosted in a virtual environment. Very, very important, everyone. This is a big one to get you some more CPU power. Next, how many of you guys actually inherited a database server where every single service available in the install was chosen? What happens is each one of these consumes some of your resources on your box. You want to make sure you are only running services that pertain to your engine on the box, okay? If you have to share that box with SSIS, SSAS, your reporting services, each one of those is going to take resources away from your engine. And that's where I need the most resources that are available on this box. I don't want to share it. Of course, because of licensing, there are many times that we have to have SSIS, for instance, on the same box. We're going to take that into account when we do a couple of the configurations like memory to make sure we allocate accordingly. But if you're on your box right now, please take a look at your services. If you're running all of these services and they're not in use, you're not using it at all, please turn them off. Make sure you're not only turning them off, but switch it so that it's set to disable. Some of these will actually turn back on when you reboot your box if it's set to automatic, and we end up in the scenario again where we have multiple services running that we do not need, okay? So take a peek at your services, and please do not install anything on your box except for the engine when applicable, because you do not want to share resources with other things. So next, we're going to talk about patching. Everybody talks about patching when it comes to security, right? We want to make sure there's no loopholes. We're on the latest patch. We don't want anybody actually getting into our system. But as a DBA, we need to go and think beyond that. We want to talk about performance. Performance is so important. And with every release of SQL Server, we end up with additional CUs or KBs, things like that we have to use to patch our boxes. Well, many of the times, those changes are all related to performance. There are bug fixes. There are lots of things that are actually corrected, changed, optimized within each one of these patches. And if you are not staying on the latest patch, you have performance issues, because there are things that are fixed with every single patch. So please make sure you're on that, not only for security, but performance. The best example we have is when SQL Server 2016 RTM came out, there was some issues with the optimizers that were changed as we went to SP1. We got much better performance in the optimizer. They made some big changes, and we saw that improvement. So make sure if you're on 2016, you are on SP1 and above, you're not sitting at RTM. As soon as you make that jump, you're going to get a performance increase just by patching. There's a blog list here that actually shows all the available builds. Double check where you are on that patch level and see what you can do about upgrading it. Microsoft support, every time you call Microsoft, it costs you a lot of money for them to assist you. If you are not on the right patch level, they can easily hang up the phone and say, you are not in support right now, we can't help you, and therefore you wasted your money. So make sure when it comes to performance and everything, you keep that in mind. If you ever have to call Microsoft for support, you have to be on the proper patching level in order for them to help you, okay? Make sure it's one that's supported by them. Things outside the DBA realm that we have to think about. Everything touches SQL Server, right? We have storage, we have controllers, we have the network, we have all of these pieces. You've got to make sure those stay in line with patching as well. You could have an issue with the latest VM patch. Maybe you're supposed to be on that. Maybe there's some issues with some NIC cards. All of these other components that play a part of SQL Server also have to have patching. I actually have run into scenarios where the outside components were not patched, and that's actually what caused my problems with in my latency inside SQL Server. So take all of those accounts if you would, and think about patching more than just security. So memory. SQL Server, we want to maximize memory. We want to use it. We want to actually have all of our data, as much data pages in cache and in memory, right, in cache, for reuse. We want to be able to get to our data as fast as possible. So properly allocating our memory to the SQL Server engine helps us from having to go to disk, go to storage, which could be a bottleneck in getting our data back to our users. So we want to make sure we have this configured correctly. If you're looking at your box right now and you go to the server properties and look at memory and you see this really large number, 2417864, 7. If you're looking at this number, then you have not properly configured your memory. You want to make sure you take care of that. That number can easily be set correctly for your environment by using, there's a script out there by Jonathan Cahias. If I had that, I think I have that in my reference, that you can run and it'll actually look and evaluate your system. There's some math that go along with this, and because we don't have time, I'm not going to go into that math, but it'll actually look and tell you how much you should be allocating to your engine. There's two pieces to this, and depending on your services, a third piece. But two pieces is that you want to make sure you have enough memory allocated to your operating system, and then the rest of the memory allocated to SQL Server or whatever services that are still out there. So let's take an example. Say I have 32 gigs on my box. Maybe I actually want to go ahead and leave 4 gigs to the OS, and then the rest, the 28 gigs, would be my max memory setting here. That means 4 gigs is going to be able to be used by the server itself. And then the rest is going to be allocated to SQL Server. When it reaches that 28 gig limit, it won't use anymore. Okay, so that's kind of how it works. Now, guess what? Some of us have multiple instances, right? If you have multiple instances on your box, you need to make sure you haven't over allocated that 32 gigs, okay? If I have two and I run Jonathan's script, or I go ahead and put 28 gigs in one instance and I put 28 gigs in another, guess what? I just over allocated my memory. So if you have multiple instances, I really want you to go back and check and add up the amount on each server, each instance, of total memory that you've allocated within inside your engine properties here, okay? Make sure you've not over allocated and you leave enough for your Windows box so you do not starve it and get a ton of low Windows memory errors, okay? Next, when we have those extra services, did you know, and I catch this a lot when I'm teaching this in person, that SSIS, SSAS, SSRS, all of those extra services that are running do not share this max memory number that you have set here. That number is solely for the engine. So if I have put the 28 gigs here as my max memory setting and I've left 4 gigs to the OS, guess what? Those 4 gigs are actually being shared with SSIS, SSRS, SSAS. Have you ever gotten a lot of memory alerts or had SSIS actually be running some imports and it runs really, really slow, or you end up with some performance issues on your Windows box while those are running? It's probably because it doesn't have enough memory and you've actually starved it. Make sure you allocate enough to these services as well that it's going to share with the OS. So maybe in this instance, I should put 24 gigs for my max memory here, which will allow more available for these services and my OS to run, okay? I do have locked pages in memory noted here. I'm not going to go into it because we don't have time. I want you to research those terms. Find out if it's applicable to be turned on in your environment. There's some good things and bad things about it. It's not something that you should turn on automatically. So please take a look and just know you should know about that. Also, if you are running in a VM environment and you are on a host, there is this thing called a balloon driver that you need to know about. What happens is on a host, you share that host with several different VMs. If at one point another VM needs more memory, or it needs some more CPU, or it needs some more resources available for it to run its load, even short term, the host will allocate and pull some memory or CPU or whatever it is from another VM so it can use it to do what it needs to do and then might give it back. Guess what? When it comes to SQL Server, I'm stingy. I don't want that balloon driver to touch my box. So make sure when you have that set up on a VM that when I ask for my 32 gigs, I'm going to ask my admin to set a memory reservation. And what that means is that the balloon driver is not allowed to touch my memory. Okay, it cannot borrow from my memory. It cannot reallocate to any other VM on there. It can't touch it. That's very important. I've run into several over allocated VMs where it's actually stealing resources from my SQL Server, and I don't want that to happen. It's a very simple checkbox. Set the memory reservation for the total amount that you need for your server. Please go back and double check that. Next. Depthy went really in depth on this, so I'm going to go over it a little quick. If you didn't watch her session, I'm going to touch just the best practices on this. You can go back and watch her session later. But I'm going to remind you that one, it should be pinned to the highest disk possible. You want Tempdb to run as fast as possible. Put it on SSDs. Put it on its own disk. Don't share it with any other things so you don't end up with a storage bottleneck or any other kind of throttling that could happen on that disk, okay? Put it separately. Multiple files, she talked about that. It's all about contention. You want it to actually be able to round robin through all of those SGAM pages, the GAM pages, all of that. You want it to round robin through all of your files. So when you're actually setting up your SQL Server, if you're in 2016 or later, as you go through that GUI, it starts to give you the option for multiple files. That's how important it is. Okay, we want to make sure you're doing that. When you do that, you want to make sure they're sized exactly the same. What happens is guess what? So look at this one. All of these, if you go to your environment, we'll start again. If we go to your environment and you have one of your files larger than any of the other, all of your workload is going to go there because guess what? It has the most space. SQL Server thinks, hey, my file 1 is 25 gigs right now, and my file 2, 3, and 4 are only 10. I'm going to throw all of my workload on file 1. Then we end up with contention that she talked about. You don't want that. You want to make sure all your files stay in line. You have multiple files, like she reiterated, 1 per CPU core, up to 8 files is a good start. When you go over 8, it starts to get a little bit of throttling going on. Too many files can give too many choices, and you end up with a lot of other issues that can come along with this. But again, multiple files, keep them all the same size, make the auto growth all exactly the same size. You want them all to grow in tandem, which is where that trace flag 1118 and 1117, and that's pre-2016, come into play to make sure that happens. If you go into your environment and you have one file larger than the other, you have contention, you have performance issues, and you need to fix that and make sure they're all in line, okay? We talked about making sure you're up on your patching. She talked about this as well. There was a metadata fix. There was some contention going on behind the scenes that Microsoft found and fixed for all of us when you go to 2016 CU8, 2017 CU5. If you are on those CU levels or above, you don't have to worry about this contention. This is something that we were all experiencing and was easily corrected on a patch. So keep these kind of things in mind when you're coming to performance. It's a good example of that. These are, again, the items that I want you to look at in Tempdb. We're not going to go way into this because she already covered this in the last topic. But here's another one. Trace flag 2453, turn it on. Write it down. Make sure you go back to your environment and turn it on. So what this does is, if you're using table variables, that's the at table, when the SQL Server goes and creates an execution plan, you'll note that it actually thinks there's an estimated number of rows of 1. It will allocate your memory. It will allocate needed resources based on a row count of 1, okay? But what happens is, because it only thinks 1 row comes in, it doesn't grant enough memory, and it doesn't grant enough resources to move your larger number of rows through. And you get a bad execution plan. You may have bad joins. You may have other bad operators that it chooses, as well as not enough memory to make all of the decisions it needs to do and move those records along. 2453 does a pre-compile and will actually use the actual number of rows to grant all of your resources. So your stuff goes much, much, much faster. In 2019, they fixed this with table variable deferred compilation. I'm not going to go into that, but if you are not on 2019, TraceFag 2453 is a must inside your system, okay? Next. Here's a couple other settings that are now done as defaulted prompts in 2019. Anytime something becomes defaulted or actually gets set in your setup GUI inside SQL Server, you probably want to take note and do these things in lower environments. The MaxDP is one of them, max degree of parallelism, and its tandem partner I call the cost for threshold of parallelism. So what this does, it's all about how many threads are going to be allocated when it's working through a node or operator inside your execution plan to move your data along. In your MaxDP, what you like to set this variable at, if it's sitting at 0, then you haven't changed it. If your cost is sitting at 5, you haven't changed it. These are items you need to change. So what this does is tells the server how many threads I can give for whatever operator it is. So you want to make sure you set that correctly and you don't over allocate threads, or you're going to end up with some things called SOS scheduler yield or CX packet weights. There's things that actually happen with these two pieces. The max degree of parallelism, if you have 8 cores, or less, we'll talk about that as an example. So say I have an 8-core box. I like to say I'm going to give it half of those. So I will set my MaxDP to 4. I can set it up to 8, but I usually try to go with 4. So what happens is, of those 8, I'm allowed 4 for that operator to move that data along and go parallel, okay? So what happens from there is it says, hey, let me look at the cost. If it's set at 5, again, you haven't tweaked this. A good number to start is 35 to 50. If my cost of that operator is above 50, then I'm going to allow it to go parallel, which means in this case, I'm going to allow it to use 4 threads to do what it needs to do. And then it's got to bring those 4 threads back together before it goes on to the next operator. Hopefully you guys are following what I'm talking about. So what happens when it says, okay, I've got 4 threads, I'm going to move to the next operator. When it comes back together and brings the 4 threads back to the next operator, it's going to create what's called a CX packet weight. A CX packet weight is bringing those 4 together before it can move on. So if you see those CX packet weights, maybe it's not definite, but maybe you should look and see what your cost is. Do I need to bump that number up? Do I need to bump that number down? Take a look. If you're going to change your MaxDP and allow it to do more threads, then remember that when you make this change, don't do it live in production because it will flush your procedure cache. If you do that, you're just going to get a performance hit as all of those procs get back into cache for reuse. So just keep that in mind. But take a look at these two numbers. If you have too many cores, look at this. It says if it has 8 logical cores, you want to do 8 or less, right? When you start to go above 8, there are instances where you might have 32 cores on your box and you might want to do 16. But the more cores you allow, more threads you allow to use, the more CX packet wait time you're going to have because you got to bring them all together, and you can end up with some throttling or some overhead on that. But just keep in mind, MaxDP, my rule of thumb is half of my cores up to the total number of cores. There's some things with NUMA that I always get questions on. I'm not going to go into that. You can do some research on that. But I try to do half, and then cost again, 35 to 50 is what you want to start at, and then move on from there. So next. This one is another one that I catch all the time, and it's a big one. It's another thing that's added inside the default setup when you go to 2019, and it's instant file initialization. It is outside of the SQL Server DBA's realm, so it's a conversation you should have with your server admins, and all this is a permission, and it's so important, and I'm about to show you why it's so important. So if you look at your local policy here, inside your SQL Server, you need to make sure under local policy that your SQL Server service account, whatever is running SQL Server, has the rights to perform volume maintenance tasks. Or if you have an AD group policy, make sure it's there. What this allows you to do is when you create a file, you restore a file, you add a data file, you have an auto growth event, you create a database. On the disk, it actually has to zero out the space it's going to need to do its operation, add the log, do whatever growth it is, create a new database. It kind of zeroes that out on the disk, and then it starts to write your information. That actually takes a lot of time depending on how big of the file or growth event that occurs. Instant file initialization, IFI, will actually skip that step. As soon as I need to write to that, I need to grow or whatever it needs to do, bam, I can do it. I can skip the zeroing out operation. If you don't have this, it's possible that your restores are taking a long time. You're creating a database can take a long time. Your restarts, because Tempdb has to grow and be created, can actually take a long time. Let's look at this example here and make sure I'm on the right one. I may have to go back one slide. There we go. Let's look at this. So here's an example of without IFI. It's really, really simple. I am creating a 5 GB database, just to create database, and I have it set to 5 gigs. Without instant file initialization, it is zeroing it out, and it is taking me 1800 milliseconds. As soon as I turn on instant file initialization and I create that 5 gig database, look, it's 3 times as fast. So imagine if your Tempdb is set up with multiple files, each one 25 gigs. When it first starts up and it has to create each one of those files at 25 gigs, that can actually slow your restart process. If instant file initialization is there, that goes much faster. And you'll see you can actually restart your server faster. You can do your auto growth events faster. You can do your restores faster as well. So keep that in mind. That's another setting you should be checking on your box. So next, if it goes, clicking here, we'll go past this. Sorry about that. I'm running on 3 different screens here. Okay, we are back on track. So let's talk about blocking. All of us have experienced blocking. And many of us, I hope I didn't get everybody dizzy with that screens going back and forth. I apologize. So blocking, everybody has blocking. It is normal throughout SQL Server. It's supposed to happen. Readers block writers and writers block readers. But there are options available to us, and I call this the magic button inside SQL Server. It is called RCSI, or Read Committed Snapshot Isolation. And what this does is this actually creates row versions of version store inside Tempdb. Notice I just said inside Tempdb. First thing you should be making sure is that your Tempdb is set and configured correctly before you enable this, okay? Because it actually takes more space inside Tempdb. It needs to go fast, And we want to make sure we've set up for that first, okay? All right, so what this is it allows it to create a row version inside Tempdb. So your readers can go to the row version while the writers can actually still write at the same time. So readers don't block writers and writers no longer block readers. I can tell you there's two options: allow snapshot isolation and read committed snapshot isolation. Both of these play a part. It is on a database level, and it is the default isolation level in Azure SQL DB. So if something's defaulted, which I talked about earlier, if something's defaulted, it's usually something that you probably should turn on. I call this the magic button because I can tell you exactly when you've experienced a ton of blocking, when this has been turned on, because all the blocking disappears. When all the normal blocking disappears. Your readers blocking writers and writers blocking readers, okay? Because it will actually go to the version store and allow these transactions to happen, still maintaining your ACID, and will allow your readers to actually get the data that it needs. Now, I have a friend, her name is Kendra Little. Kendra Little has a fantastic blog on this, so you can take a look. I do have the link to it as my final slide here, and I can get that to you. But between the two options, allow snapshot isolation allows it to read the version store, and read committed snapshot isolation creates the version store. So definitely take a look at those, read deeper into it. We don't have a lot of time for that today. But definitely take a look at this option. If you have reports that are reading from production, if you have select statements being done by your application on production, as well as doing inserts, update, deletes, which we all do, you probably can actually take a big performance gain by turning this on. And again, if its isolation level is defaulted in Azure SQL DB, this is definitely something you should be looking at in your environment. I have seen huge, massive performance gains and reduction in blocking just by turning this on. Okay, virtual log files. This is something that not everybody knows about. I wish I had an hour to talk about them. It has to do with your log file, your transaction log. I do have several blogs on this, so you can take a look. But in general, I want you to go, there is several queries on this. I do have one on my blog that you can do. I want you to go and look at all of your databases and see how many VLFs, virtual log files, you have in your environment. If you have a virtual log file count under 300, you're probably in a really good state. If it's over 300, and I have seen hundreds of thousands, especially inside Tempdb, be created, then you have an issue and you have a performance issue. If you're looking at this picture here, it's very, very simple, and I'm just going to give you a high level of how this works. Is inside your transaction log, you're going to have several different segments, virtual log files. These virtual log files are created every time you have a growth event. There's math involved for each several megs that you get created. Several different virtual log files can be added to your log file. We'll show it like buckets. If you think of these things as buckets, when I have a transaction that needs to be written to the log file, it finds a segment inside this bucket to write and do its work. So it does that round robin thing through all of these virtual log files. You can imagine if I have hundreds of thousands of log files, if I have 1,000 log files, that's a lot of buckets it has to go through as it's going through our transaction log, right? We want to minimize that full trip around finding those empty buckets and where it's supposed to start, okay? So if you've got larger than 300, then how do you fix it? One, you've got to shrink your log file down, and then you need to regrow it. You need to set its default growth at whatever's ideal for you. Maybe I used to have it set at 100 megs. Maybe it needs to be a gig. If I have it set as a gig, then I'm going to have less virtual log files. If I set my auto growth, if my auto growth is set to 5 megs, I'm going to get a ton of VLFs every time it needs to grow. If I set it to 250, I'm going to have less. So you really need to look at what your auto growth setting is. Please do not set it as a %. You need to have it as a number that makes sense for your environment and how much data you're pushing through in your environment. So if I have it at a larger number, then I'm going to have less virtual log files in my system. So take a look, run the script that I have on my site, or you have the DBCC log info, or in 2016 SP2, they have a new DMV that you can pull through log stats and get those counts. If your counts are high, you need to make a correction, because this is actually a big performance hit that you get on your log file by not having these set. This is something that you should be looking at probably quarterly, like you do maybe your index maintenance, things like that. This should be one of the things you look at and try to keep in track, okay? There's tons of information out there. Again, I have a blog on it with a script you can use to check your environment as well. So ugly babies, if you've seen me talk before, I try to talk about this every time because it's so important to performance. Make friends. Please make friends with your network admin, your storage admins, because performance is reliant on other components outside of your SQL Server agent, your SQL Server engine. We all know we have that best configured as possible, but maybe the network is not configured correctly. Maybe the storage is not configured correctly. There's lots of things that are outside our realm in the hands of other admins that actually make a performance impact for us. So I like to say, keep your admins drunk, fat, and happy, right? If you come into a new environment, maybe you need to buy donuts for the network group, or maybe you need to take the head network admin out for pizza or something before you ask them to make changes to their VM and reserve the memory that I told you need to do. There's lots of things that you need to consider when you are talking performance inside SQL Server. A lot of things having to do with storage. Storage happens to be one of the worst bottlenecks for SQL Server. If it's not configured correctly, if you're not on the fastest disk, if they have not allocated things to you correctly, which we will talk about here in a minute, that's an ugly baby scenario. And we've all run into issues where somebody's come to us and blamed the DBA for a performance issue. It's always the SQL Server. Always the SQL Server that's an issue, right? Well, it's very easy for us to run different metrics in our environment. We have lots of tools out there to show what the latency is in our environment and where that latency is coming from. We can look at wait stats. SOS scheduler yields can be a throttling thing that happens on a VM when it comes to the CPU allocations, right? There's lots of things we can actually give numbers that can prove these other items are a problem. So make sure you're working with your admins, because you're going to be calling their babies ugly, letting them know what's wrong in their system, and you need them to fix it, okay? So make sure it's a huge thing when it comes to performance. Some of the ugly babies I just kind of mentioned is on your VM side, right? When you're in a virtual environment, you're sharing that host with several different other VMs. You don't have purview. You can't see into how they've set up that host. Luckily, if you've got a nice admin and you've actually bought him or her pizza and taken them out for lunch and asked them, hey, can we give me read-only view to see what's going on in my host, right? You'll be able to identify things as too many. Maybe you have too many VMs on one host. They're using that balloon driver and it's stealing resources from you. You'll be able to see that. What happens on one VM can really mess up another. Maybe they are moving you from one host to another and you don't know this. Maybe they shift you daily, and that happens to coincide with data imports that you're doing, and you find out that that's the problem. They're actually moving you from one host to another for whatever maintenance reason, and that's causing a problem. These are the things you need to look at. Over allocation of CPUs. How do you know how much CPUs have been allocated on that host? For example, I had a really large retail client that went down. Their whole system went down. And if you recall, there was that patching that happened for security, that Spectre meltdown patching that happened. What actually occurred was we had a box that CPU was through the roof. It was at 100%. It was unresponsive. We couldn't do anything. I found out it was actually on a host, and they said, we haven't touched that host. There's no reason why it has an issue. Come to find out, the night before, they installed the VM inspector patches, and it took away the hyperthreading. If you don't know what hyperthreading is, if I have 32 cores on my box and it's hyperthreaded, then I really have 64 cores, threads that they are able to allocate for all of their VMs. Well, guess what? When they put those patches in, it took away hyperthreading. So I was back to the 32 cores for that entire VM. Looking at what they did, they actually allocated 96 cores, 96 CPUs, 96 virtual CPUs to the the VMs that were on that host, they completely over allocated. So once they put that patching in, we had the 32 put to the 96. They were all trying to share and get to those 32 threads, and we couldn't get it fixed because this had happened. I didn't know this as a DBA. I happened to ask the right questions. I was seeing the SOS scheduler yield weights, and my CPU ready time on the VM host was very, very high. So, very, very low. So I knew that there was an issue on the host. These are things that you can run into. And the other thing, thin provisioning. What's thin provisioning? So let's say I go to my admin, this is a storage admin, and I say, hey, I'm going to create a new Tempdb. I need 500 gigs of space on a T drive because I want to put it on a separate drive. They said, Monica, no way are you going to use 500 gigs for a Tempdb. I said, yes, I am. I'm going to go ahead and create those, and I want 500 gigs. He said, okay, I will give you 500 gigs. He gives me a T drive, and on the T drive, I see 500 gigs. But what they really did is they thin provisioned my drive space. What that means is maybe it only allocated 25 gigs, and then when I need more, it will give me another 25, and then another 25, and another 25, and it will actually grow to give me the full 500 over time. Well, every time that growth event happens, I get a performance hit inside SQL Server. So when I ask for that 500 gigs in the beginning, I need to ask for 500 gigs thick provisioned. That means I want all 500 gigs at one time. I don't want it thin provisions where I get segments as it grows and gives me that. If they decide that no, they are not going to do that, then what am I going to do? I'm going to go around them, and I'm going to go ahead and set my default sizes on Tempdb to 100 gigs a piece or 125 gigs a piece, and I'm going to take all 500 gigs at one time. That way, I don't incur a performance issue when those growth events happens. So have the conversations with them. There is a thick provision, which is what you want. Thin provision is the sneaky little thing that they'll try to do and only give you a little bit of space, okay? So have those conversations. Make sure you're getting it thick provisioned. The next thing I want to talk about is compression. Compression is a great thing. It allows me to actually compress the data on a page, which allows me to get more data on that page, which means what? More data into memory. The more data into memory I can do, the more quicker I can get my data and get that data back to my users or my application. We want to keep as much memory or much data in memory as possible. So we want to go ahead and compress page compression and row compression. Page compression is actually going to compress everything on that page. Row compression is going to take care of the extra space you might have on a row. So if you have varchar 100, for instance, and you're only using 25 out of that, it would compress and bring down the empty space and get that all taken care of and take it away for where it doesn't need it. Okay, so that's the difference between page and row compression in a small summary here. Okay, so we want to actually definitely use that. It saves space on a disk, and it actually will cost you a little more in CPU speed, but what you get back is totally worth it if I can get that data back faster. Now, here's where the ugly baby comes in, a backup compression. Backup compression. Backups are so important, but the most important part is the restore, right? The restore. You want to be able to restore your data as fast as possible and as efficiently as possible, especially when you're in a scenario that brings the entire environment down. What comes into play here is when your storage admin comes to you and say, hey, Monica, you're not allowed to use compression. If your storage admin comes to you and say, you're not allowed to use compression, you need to have a conversation. The reason why they're telling you you're not allowed to use compression is because they are doing compression and deduping on the SAN side. What that does is allows them to store less data on the SAN, get more space out of the SAN, and it uses things called pointers to actually point to the data and not bring over duplicate data. So the actual duplicate data becomes a pointer to what it needs. So it actually saves them a ton of space. But what happens for you as a DBA? When I actually have a backup that's going to a deduped storage array, the disk, then I have a restore that now has a ton of pointers. What happens when I actually have to restore that data? All of those pointers have to come back together. All that data has to be rehydrated into its form before I can restore. So we've had scenarios where I have a native SQL backup. I've stored it on a deduped storage array because I wasn't allowed to compress it, and they've started doing the compression on the storage array. It took 24 hours to restore that data. Now, if I had a native SQL backup saved to the cloud or saved someplace else that I compressed that was not on a deduped SAN, it took 1/3 of the time. 1/3 of the time. So if I have a downtime scenario, I would rather take 2 hours to do a restore than 12 hours to do a restore, okay? Or whatever it is math-wise. But you get the point. If I have to restore and we're in a critical downtime, I do not want to have all that deduplicated data rehydrated before I can do my restore. So my point is, if your SAN admin says you cannot compress your data, or please don't compress your backups, or you can no longer do that, or that they are deduplicating the data and doing the compression on the SAN side, you need to have a conversation with them and make sure that you are putting your backups elsewhere into the cloud or on something that's not deduped so you can do that restore properly. If they say you cannot do that, then I want you to do a test. Restore your data with the deduped restore, and restore your data with your regular native backup, and show them the time difference. If you can get somebody to sign off on that in writing and that's okay with them, fine. But definitely take the time to get somebody to know that before you actually say okay and don't do the compression on your side, okay? It's really important. So let's talk about this. Statistics. Statistics is the magic sauce of everything. Every query that you put through, the optimizer needs to know how many rows to expect, your estimated versus actual rows. We've talked about this several times. We all know this. The closer in sync the estimated rows to the actual rows are within your environment, the better. The better the optimizer can choose which joins to do, what memory grant to give, and your actual query performance can be much improved. Well, you want to make sure you keep these up to date. It's your job as a DBA to do that. I recommend not only doing your index maintenance, but statistics maintenance. Make sure that you're running a job, even if it's update statistics all. There's several different things. My friend, Erin Stiletto, has a fantastic session on this. I highly recommend her blog when it comes to statistics. Keep these up to date. Make sure you're running the statistics updates daily, nightly, whatever it is, depending on how often your data changes, okay? On a database level, there is also a update statistics. If you're using the auto statistics, which most of us are, and set by default, there are two options you have available. There is asynchronous and synchronous. I highly recommend you move this to asynchronous, which means my data can continue to be read while my statistics are updated when it has availability to update. When it gets an auto statistic update, you've hit the threshold of rows changed, it wants to give you a new statistic and generate that new statistic. Well, when that happens, things kind of pause and a wait is created in the background for that statistic to update. You can circumvent that wait by changing it to asynchronous, which will allow your data load to happen, and then your update stats will wait, and then it will run when it has the availability to do so. It's a small little tweak. I do have a blog on this as well. Take a look at that and make the change if it's applicable to you. If you're dealing with large tables, this is another trace flag you need to write down. It's 2371, and it is defaulted in 2016. Remember I said if it's defaulted, you probably want to take note. If you're below 2016, you need to turn on 2371. And what that allows it to do is it changes the algorithm of how statistics updates happen. Those auto statistics are important. If I've got a table that has millions and millions of rows, and it needs a 20% change plus whatever the algorithm says how many rows it needs to do before it triggers an auto stats update, you could be waiting a really long time and your statistics can get stale, which means your estimated versus actual rows can get way out of sync. We don't want that to happen. 2371 changes that to a sliding scale depending on how big your table is, and will change that algorithm, which will trigger that auto statistics updates quicker. So definitely put that down. There's no adverse effect to this. I haven't found any. I don't know of any. And again, it's defaulted in 2016 and higher, so pay attention to it. Those developers out there, if you're missing if you're looking at your execution plans, it could actually tell you there's no statistics. If it tells you it's no statistics, then you probably want to make a statistic on the column it's looking for. And or if you know that you're going to be using a particular field or a multi-field combination when you're doing your reads, maybe adding a statistic and giving the optimizer a little more information about those rows can be helpful to your performance for that query. So take a look at that. You can actually right-click on your database, create statistic, and create your own statistics, something a lot of people do not do but can do. Indexes. I'm going to take a drink real quick. I think we have 20 minutes left. So indexes. Indexes are so important. We all love indexes. They're magic. We talk about in where I work in Denny Cherry and Associates, we say indexes are magic, and we actually have stickers for it because they are magic. Everybody wants to add an index to make things go faster, but making sure you have the proper indexes and you are maintaining the health of your current indexes is what really matters. You want to make sure you are using your IO on your system effectively. If you are actually writing to indexes that you're not using, if you have duplicate indexes out there and you're writing multiple times that you shouldn't be, you need to actually make sure as a DBA that you are not doing that and you are properly using your IO and not wasting it. So I want you to go and script out all of your indexes. There's plenty of queries out there to do so. SQL Skills has some queries. I have some queries. We all do. Script out all of your indexes. I want you to put them into Excel. I want you to sort them in column order and in included column order and go through all of them. It's not rocket science, and see which ones are duplicated. Check and see if you have the same index and the only thing that's different is the included columns are different. That's an easy consolidation. Bringing that to one index will save you IO, and it actually gives the optimizer better choices for it to actually have the proper plan for you. So go through quarterly at least. Look at all your indexes. You can actually run scripts that tells you seeks versus scans and updates. If I have an index that has very little seeks, lots of scans, maybe I need to look and see if that index is the proper order. What if I have 0 seeks, 0 scans, and a ton of updates? Guess what? That index is not being used. Maybe I need to script that off, disable it, and get rid of it. I will save an IO. Now that leads me to missing indexes. Missing indexes. Everybody's seen an execution plan where it actually says you're missing an index and will tell you how much improvement that has. Guess what? Please don't do that. I want you to go ahead and look at the query you're running and look at the query or that index that it's actually told you to do. First step when it does that is to script out that index and look and see if you have an index that already exists. Lots of times, all you have to do is add an additional included column and you fix your problem. If I actually scripted it and executed it and created that missing index, I end up in a duplicate index situation. I wasted IO. Don't do that. Also, the way it gives you the missing indexes is it will actually put them in table order. So I need to know my query enough to know what order to put those fields in. Don't just right click and add these indexes because you're going to end up with duplicates and wasted IO. I can't say that enough. Secondly, let's talk about covering indexes. What is a covering index? A covering index is I am covering everything in my select, my joins, my wheres, my group bys. I've got it all in one index. So therefore, I can actually stay away from these things called key lookups or RID lookups, which I'm going to talk about here in a minute. I want to make sure that I cover my queries that are run multiple times. Maybe I have a query that runs hundreds of thousands of times an hour. I want to make sure I have the most efficient index possible and I have the included columns that I need. I have a lot of people ask me, should I include, if it asks that missing index, remember I scripted it out first before I actually run it. If it tells me to include all the columns in my table, I might want to take a step back and see what exactly is my query doing and do I need to actually have all of those columns? Probably not. There's a possibility that you might, but probably not. So take a look at those first. Again, when I'm talking about all of this, it's very, very important for you as a DBA to know what you're creating and executing when it comes to indexes. Okay, so let's go to the next thing. If it will go. Multiple screens don't always work, everybody. Okay, so here's my final one. Simon, I think we finished at 11:50. I'm going to make sure that we we don't go too over for you because I don't want to impede on Kathy because I know she has a great session later. But when it comes to execution plans, this is what we care about. A lot of us as performance tuning know we need to go to the execution plan level to really see what's going on by the optimizer and how it has chosen to run our data load. Some of us are new at performance tuning. We may not know what a nested loop is. We may not know what a merge join is. We don't know what to do with each one of these operators and how to make things faster. So I'm giving you a little bit of a checklist of what to do when it comes to execution plans. Double check your needs, your index needs, which we just talked about. Sorts. Why are you sorting? Sorts are the highest used thing. Sorry. Sorts are the most expensive thing inside of an execution plan. Why are you sorting? Have you written a store procedure that goes select, order by, select, order by, select, order by as you've done your development? So what I want you to do when you're doing your writing and your development work is if you're going to test and you're going to sort as you do your development, make sure you remove those order bys from any statement that you don't need before you move to production. If you can sort at the very end one time, that's what you want to do because, again, these are very, very expensive things to do. Guess what? If you're using that store procedure for a report and they're actually going to be sorting in the report anyways, why are you sorting inside SQL Server? Why are you having this query do the sort for you when they were going to resort it several different ways in the report? Take that sort out. You'll see that things run much faster because sorting, one, if it's not able to sort in memory, it might sort and spill to Tempdb. And or, again, it is the most expensive thing you're going to see inside an execution plan usually. So ask the question, what's happening with the data? Is the application sorting it? Is a report sorting it? And see if it can be done elsewhere. Key lookups. Now, key lookups, everybody has them in your system, and I want you to know where they are in your environment. Key lookups can be death by 1,000 cuts. I can go into a system, clean up all the key lookups, and improve their performance drastically. It can be like a brand new box by just getting rid of these key lookups. You'll note here in the picture, I've got a query. It goes against order lines. And all I'm doing is I'm selecting column A, B, and C, where column C equals 1. Okay, let's say that. So I have a column C index. This actual order lines, this seek is happening on column C. It's in my where clause. It knows exactly where to go to get the data. A seek is great. That's what you want. But it does a key lookup to grab column A and B. Column A and B was part of my select statement. So it goes and finds C. Then it goes back to my actual primary key. You can see that here. Goes to my primary key, finds a match, and then brings all the other columns along, A and B. If I hovered over key lookup, it will say output list A and B. So now I've got A, B, and C using these two items. It brings it to a nested loop to bring it back together before it goes to my select statement. So what did I do? Instead of just going from a seek to a select, I've made an extra read over to my primary key to take the extra column I have in my select statement. I can fix this really, really easily. This might happen. Maybe I have a store procedure that I have 10 key lookups in. Well, that store procedure is run 10,000 times an hour. You can see how all of those extra trips to my primary key can cause a ton of overhead and can slow things down. Easy fix. I highlight over the key lookup operator. It tells me the output list. I go and I modify that order lines index that's used in the seek right above it. All I have to do is add the included column A and B. Again, that's included column A and B. And guess what's going to happen? It covers my index. It covers my statement, my query statement. And I get just a seek and a select, and that's it. So I've saved a ton of IO, a ton of round robins out to my primary key to get extra data by covering my select statement in with included columns, and I get rid of these key lookups. The death by 1,000 cuts can happen really, really, really easily in your environment. And there's an easy way to find key lookups. Again, Jonathan Cahias has a fantastic blog and script that you can run to actually get all the key lookups in your environment and start to tackle those. I have a blog that links to his that it's actually my #1 blog is what's a key lookup, where you can actually find out in your system what key lookups you have and easily fix those and give yourself a huge performance thing. Let's talk about Tempdb one more time. Everybody knows what a spill to Tempdb is. What a spill to Tempdb is it did not grant enough memory for me to do whatever operation that had to happen. My estimated versus actuals were really skewed in my row counts. And so therefore it didn't give me enough memory to do whatever operation it is. So it spilled to disk, spilled to Tempdb because Tempdb is not in memory, it's in disk. So it spilled to Tempdb to do its workload. Okay, so when I go to my Tempdb, it's on disk. Guess what? My disk could be a bottleneck. I want to stay away from this. So you don't want to have a spill to Tempdb. How do I fix it? One, I make sure my statistics are up to date, so my estimated versus actuals are correct. That's the #1 thing. There's several things coming in 2019, memory grant feedback, stuff like that, that actually helps us stay away from these spill to Tempdbs. But take a look, do some research on this, know what they are, know what you need to do to avoid those. You want to stay away from your bottleneck, which is your disk and Tempdb. All right, so that's everything. I tried really hard to give you guys this whole session. I know I really went fast, but I want to make sure you guys got all the information you need. My blog is here. I'm on Twitter. You can send me any questions you have about anything in this checklist. I do have some reference links here that we can copy these links out. Sorry about that. We can copy these links out for you, and I'll make sure I have them and put them into the chat for you guys. All of these is what I talked about, how much memory, that's how you get your max memory. My what is a key lookup? Let's talk about compression. Remember that async versus sync update statistics. I want to make sure you guys have that. And remember the magic button I like to talk about, which is that RCSI, which will get rid of a lot of your blocking. So here's all the references. I will make sure you have it. Thank you so much for coming. I'm going to turn it back over to Simon. I know Kathy is here. I'm very excited to watch her session. She has a really great one. She's a fantastic speaker. Thanks again, C# for having me.